famous Gartner Magic Quadrant for cloud service infrastructure as a service. We are very proud that AWS is the leader in that segment for the 9th consecutive year now. And there are many reasons why AWS is maintaining this leadership position. One of the most important ones, in my view at least, is our customers and our passion to develop the best for them. This is a partnership with a deep commitment from our side to ensure our customers can focus on the core business expertise and best serve their customers, while we focus to innovate on the infrastructure around the globe, on the services and the tools that make all of that possible. One example of our cloud segment leadership is our global infrastructure. AWS Cloud spans 69 availability zones around the world. Each availability zone comprises of multiple data centers, just to give you the sense of the scale. And those are deployed in 22 geographical regions around the world. And we continue to invest and innovate. We just announced plans for 9 more availability zones and 3 additional regions coming soon in Cape Town, Jakarta, and Milan. Since we launched the FPGA instances in 2017, we doubled our capacity worldwide with a total of 8 regions around the world. FPGA, which means that FPGA application developers can now launch products globally with a few clicks of a button and do that at scale that isn't available anywhere else in the cloud. Any Canadians in the room today? Yes, one. Good. So today, I'm very happy to announce that we just added the EC2F1 into our Canada Central region in preview. And we'll continue to do so as customers come and give us more use cases and want to start businesses in other regions of the world. So let's move on to see a few examples of what customers are doing with AWS FPGAs. AstraZeneca is one of the world's largest pharmaceutical companies. They were able to build what is possibly the fastest and most operationally efficient genomic sequencing data processing pipeline in the industry. The solution is using the AWS FPGA instances to crunch the genomic data securely, and many other AWS tools and services, most notably AWS Batch for job queuing, and the highly scalable and secure S3 storage. It's important in the genomic industry and other industries to maintain security. We're talking about genome data that comes from humans, and we are very proud that companies like AstraZeneca rely on AWS and our FPGAs to process that data. As of late, they pipeline processed more than 100,000 genomes, and they did that in 100 hours. As a comparison, if they would do that on CPUs, it would take them more than 3,000 hours, and an order of magnitude more expensive to do so. And by the way, they reported that the results that they received with the FPGAs compared to CPU were more accurate. So this is helping them drive research in cancer and other chronic diseases, and we just can't wait to see results of that with work. AstraZeneca believe that they can run it even faster with improvement to the pipeline that we identified together. And in total, they plan to analyze around 2 million genomes by the year 2026. So it's truly an amazing feat. Talking about security, Trend Micro is a leading enterprise network security provider that's just launched a high-performance version of the network security appliance on the AWS marketplace. Trend Micro relies on AWS FPGAs instances to deliver network security solutions that have unique advantages such as predictable network application performance and unparalleled efficiency and operational simplicity, giving our AWS enterprise customers the ability to span from on-premises Trend Micro appliances directly to the cloud with one pane of glass control and in a way to control their overall infrastructure in a secure way. I want to take a moment and recognize our FPGA cloud segment leadership could not be possible without our great partners. Many of them are here today with us in this room. When we launched the service, we only had a handful of partners, literally a handful. And we invested a lot in kickstarting the ecosystem together with Xilinx, Victor and the team. And today we have more than 50 qualified partners, more than 35 applications on the AWS marketplace that allow AWS customers, that most of them don't even know what an FPGA is, to easily explore, test, and instantly deploy FPGA-based applications at a global scale. Therefore, accelerated solutions span many segments of the market, from security to video and imaging, processing, data analytics, fintech, and general HPC applications. One of the coolest things are that Amazon teams themselves started to adopt FPGA technology on this very stage last year. Twitch and Edge Encoder jointly announced the video encoding solution that runs on AWS FPGAs. And I just can't wait to see what more will come in this coming months. If you're interested to learn more, I invite you to come to our booth. We also have a session later today and more than 30 partners that will present solutions throughout the next 2 days. And with that, please welcome Vin.
Thank you, guys. All right, I know what you're all thinking. If there's not one but two AWS engineers on stage, we're probably going to build and launch a new service as we speak. You might think I'm kidding, but it is this relentless pace of innovation that brings hundreds of thousands of customers to AWS. And just for AI services alone, we now have several 100,000 customers working with the AWS platform to deliver machine learning at scale to a large number of use cases and applications. And it's by listening to these customers that we're starting to build and understand newer services and newer capabilities. And for example, some of the things that we're noticing is that the prevalence of deep learning models, and it's certainly no surprise to most people in the audience here that it's something that has seen an enormous traction in computer vision, in natural language processing, in speech and text analytics. But most of the applications today are built with frameworks that have provided the core building blocks and the structures for developing these machine learning models. Frameworks like TensorFlow and MXNet and PyTorch. And we certainly see customers coming to AWS with the need to build those models in these frameworks, and we support all of them. And one of the cool things about the AWS platform is its ability to serve all the customer needs from whatever framework and from whatever target platform they want to run these models. Now, one of the things that we've noticed is that as customers come to us, they find that it's really hard in many cases to work within this framework to build a machine learning model and to deploy it at scale. Frequently, there's a fairly complex workflow that starts with preparing the data, being able to label the data for training purposes, and then take that data and set it up in such a way that you have an environment where the machine learning model can be trained, and to create that staging environment for the machine learning model's training to be then further tuned for accuracy. But one of the key problems that we notice is that even after all this work, we still see a relatively sparse pattern of deployment of machine learning models at scale. And I say that with all humility because fundamentally we would like to see the world infused with smart things. We'd like to see every device, every cloud-native application, every data store infused with the machine learning capabilities that are being built in the cloud. And for that deployment at scale in production, we find that there are several things that hold back the deployment. There are several things that we find developers and data scientists struggling with, and this is fundamentally the problem that SageMaker Neo sets out to solve. The first of which is that as machine learning models become more and more accurate, particularly deep learning models, they start to add many more layers to handle the representation of whatever function the model is trained to hold. And as the machine learning models get more and more complex, they tend to be attached to the framework in which they're trained because all of these functions and primitives come from the framework. Now, taking the model out of the framework is fundamentally the challenge that we'd like to address. And the way to do that is a little hard to do when you're looking at the framework being ported to various target hardware platforms. So one of the ways we get around this is by providing what looks like a compiler as a cloud service. And it's essentially, compilers are not a new technology, but it's something that we've been working with for several decades. But the promise is essentially the same, but delivered now to deep learning models. And we look at the compiler in combination with the runtime fundamentally, SageMaker Neo provides this ability to abstract the model out of its framework and deploy wherever you want it, in whatever platform. And this is how we are able to address the needs of customers like Coupling Engineering, who took this approach of taking SageMaker Neo to train a model in SageMaker, but then to optimize it for the Xilinx platforms on edge devices as well as in the cloud. And it's this type of collaboration that we're looking to engender, to encourage with more of you, and to bring with the collaboration between Xilinx and the SageMaker Neo team, the ability to train a model in SageMaker and deploy it at scale in the cloud on F1 instances, as well as at the edge on Xilinx-based devices. So thank you, look forward to the opportunity to work with you, and with that, I'll turn it back to Victor. Thank you.
So Vin, you know, being part of SageMaker Neo is so exciting.